Trees. Have you heard of Team Trees yet? Right now, YouTube is putting on possibly the biggest collaboration in the history of the internet, where a combined subscriber base of 750 million people are pushing Team Trees. If you haven't heard about it, Team Trees is an effort to plant a lot of trees around the world. If you go to teamtrees.org and donate to the Arbor Foundation, for every $1 donated, we will plant a tree eventually. At the time of this live stream, there are over 11 million trees pledged, and the goal is 20 million by the year 2020. It feels like we're gonna get it, but why? Why are we trying to plant all of these trees? What would all these trees actually do? Well, obviously planting a lot of trees would be good for the environment, but let's get into some of the numbers. So, as part of a tree's normal respiration, trees take in carbon dioxide from the air, which is a greenhouse gas, and emit oxygen. It's part of the lungs of our planet, so to speak, and it's very good for us as oxygen-breathing creatures. A tree gets around 90% of its mass from carbon dioxide straight out of the air. The majority of a tree comes directly out of the air in the form of carbon dioxide. So when we think about aiding global warming and climate change, trying to fight it, sequestering the carbon dioxide in the trunks of these trees is a decent idea. But how much can we actually accomplish with, say, exactly 20 million additional trees? Well, a recent study estimated that the average tree pulls in about 48, nearly 50 pounds of carbon dioxide per year. Now, that doesn't sound like a lot, but again, we're talking about 20 million trees. And if we round up just to 50 to make everything nice, if we have 20 million trees, then this will be 1 billion, it's about 960 million, 1 billion pounds of carbon dioxide per year pulled straight out of the air by all these new trees at the behest of Mr. Beast. Now, what can this do for the environment and for our global climate change problem? Well, for example, let's compare it to something. The average car puts out 4.6 metric tons, 4,500 tons thereabout, of carbon dioxide each year. So if we divide the pounds here by that 4.6 metric tons and we convert the units, because we're using metric because it's easier, you find that planting 20 million trees per year will replace the equivalent of about 95,000 cars. That's great. That's making a tiny dent, but is it a big enough dent? Well, anyone who represents Team Trees will tell you this. This is not the solution to the climate change problem. 20 million trees won't exactly do it. If we do not reduce our global greenhouse gas emissions, do you know how many trees it would take to suck all that carbon dioxide, all that extra carbon dioxide out of the air without lowering emissions as well? It would take about 1 trillion, which is 50 times more than we're planting now. And to plant just all of those trees, you would need to take up an area equivalent of about 1/3 of all of the space that all of the trees on Earth take up. So you'd have to eliminate just about every natural ecosystem and farmland and stuff just to plant enough trees to equal the amount of carbon dioxide, extra carbon dioxide that we're putting out now to fuel climate change. So trees just by themselves are not the answer, but if we plant enough trees, we help deforestation, we take additional radical steps to reduce our emissions, this could be part of the solution. Right now, Team Trees is hoping to show that we can come together, we can make at least a statement, and we can do something positive to show that our hearts and minds are in the right place. So what can all these Team Trees what can the Team Trees effort do? Well, it can replace almost around 100,000 cars worth of emissions per year, but it's more of a statement to show that we are serious about this and we can do it. And you can go to teamtrees.org if you want to donate. Hello, and welcome to another edition of Because Science Live, the live show on this here channel where I take all your comments, questions, and weird comments about my hair and face, and I try to answer them, with the gusto of a pine tree. I don't know. I like evergreen questions, but I'm not an expert. I'm not a working I'm not a working scientist, but I know a lot about a little science stuff here and there. So if you have any questions for me, you can put them in the chat on YouTube, and Voice of the Void Nate will get to the best ones. If you're spamming, if you're impersonating, we will never, ever, ever answer you. Nate, what we got?
We got some good questions. Are you falling apart, Kyle?
Dude, I'm good. We're planting trees. It's a Friday, I think. It's hard to tell in here. Don't forget to set your clocks backwards or forwards.
From Hypna.
Daylight savings time should die. There's a lot of economic reasons why that's the case.
What would you make if you could use light to create matter besides money?
I think you should cut out the middleman for that question. If I could make anything like replicator style, what would I make besides money? My first thought when you said that was to make an igloo out of bread loaves. I don't know why I thought that, but it'd be fun. That's all I got. Oh no, I'd like to place myself in a swimming pool's worth of warm rising bread dough. What, do you not? Nate,
from Tony.
That's a real answer.
Are you sure?
Yeah.
From Toady Weeby.
Hey.
When we travel in space, why do we never go towards the sun? Is it a gravity or a heat issue?
Yeah, so in space, we obviously orbit the sun. So if the sun is here, and the Earth, this is not to scale, and then the Earth is here, we travel in this here pathway around the sun in a circular-like fashion. Here, so why, I believe you're asking, why don't we ever travel straight into the sun? Well, that is because this velocity here has two components. So if it just had an x component, here, we would fall into the sun because gravity is acting to point directly towards the center of rotation, and the Earth would go right into the sun. But don't forget this part of the velocity vector here. Because we are always traveling, because we always have a substantial tangential velocity, we are always falling around the sun. We are being pulled towards it, but we're also being pulled towards it as we go further away from. We're being pulled towards it as we travel away from this circle it's trying to create at a very high velocity, and that creates a circular pathway that keeps us going around the sun. If we were to stop the Earth in this, if we were to give the Earth a tangential velocity of 0, if we were to attach rockets to one side and cancel out this orbital velocity, we would fall straight into the sun. But as long as we are going fast enough around the sun, we will maintain a stable orbit around it. And this is what rockets try to do. I know when rockets take off, something like Cape Canaveral, it looks like they go straight up. But if you've seen a rocket launch before, you see them go up and then they almost go completely to the side. And that is because they have to escape the atmosphere and then they start rocketing around the Earth so they can get this velocity so they're not falling down in the orbit. If they go fast enough with this tangential velocity, they can maintain this kind of orbit. For Earth, that's around 30 kilometers per second, which is about 3 times escape velocity on the Earth. So we're going really fast around the sun. So even though the sun is pulling on us a lot, we're going so fast that we stay in orbit around it and not falling straight towards it. And that's part of how the solar system formed. When gas and dust was forming around the star and accreting into planets, it was already moving in this motion around it. That's how all this stuff came together and coalesced into a planet in the first place. If it was motionless, then it would fall right into the sun. What's next?
From Matterbeam.
OGMB, what up?
Kyle's been doing Because Science for so many years now.
271 weeks in a row without a vacation.
How does he keep the ideas coming and making consistently good quality episodes? What's the special ingredient?
Thanks, MB. I'm not gonna lie, it's a grind to keep coming up with ideas that I think are entertaining and fun and put them out for the last 271 weeks in a row without any breaks. I'll say this. Unlike, I'll say this. This is my day job. I think when you watch YouTube, and rightly so, you get the impression that a lot of people are doing, YouTube or making educational videos as a side gig, and many people do this, and that's totally fine. This is my 9 to 5. So I come in to work, to the void, I sit down, I start writing, and I'm writing, researching, doing math, scripting, producing, for 9 hours a day every day, and then I film videos on during work hours as well. So it's all I do. So it's literally a job. So I keep coming up with stuff as part of my job. It's just part of my week. It's like getting a report done or what have you. I have people like you and people like the super nerds out there who are constantly giving me ideas, constantly sending me messages on Twitter, on Facebook, on Instagram. That helps a lot. And then, I'm just a big old nerd. I'm always interested in whatever's coming up next. And I have questions about everything. Everyone who knows me knows that. I never let anything lie. Not even sleeping dogs. Nate, stop looking at me like that.
I'm not looking at anything.
Do you even have eyes?
From Soul Harvester.
Cool.
Soul Harvester.
There you go.
Yeah.
Oh, can you do a voice for every commenter's name?
Sure.
Okay.
From Soul Harvester. Can donut-shaped planets exist?
So donut-shaped planets would be very hard to construct if for nothing other than gravity, when you have a lot of mass, gets really strong. So let's say we're looking at this, straight on, and we have a ye olde donut here. Think about the gravitational forces on this. So when you have something like a sphere in space that has a lot of mass, Earth has 10 to the 24, a trillion kilograms, the gravitational force acts to pull that object into a sphere because gravity acts from all directions more or less equally if the mass is distributed equally. So if you're pulling in all directions, like this, it all pulls through the center of mass, which would be inside of this donut, if the donut is like a regularly shaped donut. The center of mass, which is just the mathematical average of where all of the weight of this thing is. So now look what happens. So instead of having, if you had a normal sphere, the forces would be equally distributed. Now, though, you have this section here that would be experiencing tremendous stress. Stress to keep this donut hole open. So the gravitational forces here would be enough to probably collapse any normal kind of matter that was trying to form this kind of shape. You could build a space station that looks like this easily, but when you have something like the mass of a planet, gravity is strong enough to force it into a spherical shape. In fact, that's one of the ways that we designate what a planet is. One of the conditions is that it has enough mass to spherify itself, that gravity has made it spherical. If it was a donut like this, I don't know if we could even call it a planet. And I don't think the structure would hold up. Not at mega scale. I mean, we would need to engineer it ourselves, I think. And even then, we might not find a material that's strong enough. What's next?
If
Whoa.
you could travel through time and witness one event personally, past or future, when would you go?
I think I'd want to watch the first atomic bomb explode with my own eyes. I don't know. If you watched the channel recently, I'm very fascinated with nuclear physics, nuclear power, nuclear weapons, and I think even though it'd be incredibly sobering, and I think it would give me a different perspective on science and power and politics and all those things to see like the end of one spectrum, to see how powerful these things have gotten and how powerful humanity has gotten, and kind of use it as like a check and balance against my own morality and my own things. So I think I'd want to see. I want to be at not ground zero, but I'd want to be on the test site for the first atomic blast. I think that would be fascinating and life-changing. I know it was. I mean, I remember Richard Feynman, one of the physicists on the Manhattan Project, genius. He was never the same after he saw an atomic blast. He was never the same. And I'd like to have that kind of life-changing moment.
Sorry, I was going to pick the accent.
Oh, please! I'm sure we're all waiting with nated breath.
Yes.
Yes. Yes. Go ahead.
Yes.
Yes.
Okay. So much pressure.
Okay. Here we go. And
from Matthew Salisbury. How long would it take for the Earth to become uninhabitable if the moon were to disappear?
Where was that person from?
I don't know. I was thinking of doing a southern accent, and then my brain was like,
Nope. Didn't quite work
I
out.
suddenly decided not to do it.
I didn't know you had a brain, or at least a physical one. The moon question is one that I get a lot from you in the chat, and it's something it's very hard for me to answer, because if we lost the moon, it wouldn't be like immediately catastrophic, like a sudden meteorite impact, a giant, continent killer meteor impact would be. If we lost the moon, we'd start, ecosystems would change because we don't have the same day-night kind of cycles with the same light going through environments. You would have weird changes to the tides. You would have weird gravitational effects without having this in our orbit. So I don't know for sure. I know it would be bad because life evolved with the moon, because the system evolved with the moon in place. It would change a lot. I don't know how catastrophic it would be. I think you need a supercomputer to run those models. And I'm probably, if you go on like an astronomy website, I'm sure someone has a better answer for that. But I'm not an expert. I don't know what would happen. Wouldn't be great though. Climate change is a more pressing problem. Team Trees, what's next?
From Esteban Benitez. How is nuclear waste produced?
Wow, I have no idea I don't know where they're from either. Nuclear waste is this is a technical term, but it's not runoff, it's not water. But nuclear waste is activated material, and by activated I mean it was exposed to radiation. It can become radioactive itself, exposed to like neutrons and other forms of radiation, other radioactive particles. It can become activated, or it's just nuclear elemental byproducts of the nuclear reaction. So you could have radioactive elements decaying into other radioactive elements or elements that are activated, and then those that material isn't useful in the energy-making process, so then you discard it. So there is a lot of waste produced by nuclear reactors, and then once it is produced, because it is so dangerous, we put it in barrels and we drop it at the bottom of a pool for a while just to hold on to it, or we bury it in a mountain or something like that forever. So there is waste produced by a nuclear reactor, but I will say that even though these products and these other activated materials are quite dangerous, the amount that we produce in the form of nuclear energy is so much less, and so much less harmful than what coal-burning power plants produce. Coal-burning power plants account for tens of thousands, if not hundreds of thousands of deaths from pollution a year. It's obviously not carbon neutral. On the other hand, nuclear power is relatively safe, even with the big disasters. It is the safest, it's the most powerful safe form of energy. You can get more solar panels and stuff, but nuclear power is incredibly efficient. It's carbon neutral. It's green. We have enough of this material to last us a long, long time. Nuclear power is going to be key in our fight against climate change. We just have to get over this stigma that we have that nuclear power is so bad. The radioactive waste is bad. That is true. But we can deal with it in a way that we cannot deal with climate change at the moment. So we need to rethink our thoughts on nuclear power. At least I have recently. Relatively safe.
Last one.
Okay.
This is from Charmander Master. Hey, Kyle.
Oh, the whole comment?
Would you ever eat any hydroponic meat? Meat grown in a lab with protein stem cells and electrified stimulation?
Wow. Would I eat a Beyond Burger is, I think, what you're asking me. And my answer is absolutely. Bringing it back to climate change, I mean raising cattle and their flatulence, because methane is a incredibly powerful greenhouse gas. It's 4 times more powerful as a greenhouse gas than carbon dioxide is. So raising cattle and steer and stuff like that for meat is a big contributor to climate change. So Beyond Beef is trying to wean us off of that. And for a long time, they were just growing the muscle cells of the animals. People would try these burgers, and then they'd be like, it tastes gross. But now, I think we are also starting to incorporate some of the fat and other things that make meat actually taste like meat. And now I haven't tried one yet, I'd love to, but I hear that Beyond Burgers are quite good. They are more expensive because it's more cost intensive, but hey, we need to change something, and we need to show the markets that with our wallets that we're willing to pay a little bit extra if it helps us fight grand existential problems like this. So I would absolutely try a lab-grown meat. In fact, I want to. And if anyone has a recommendation for where I should go to try one, let me know. Thank you so much for watching this week of Because Science. That Magic the Gathering episode, it seems like 50-50. You either totally didn't know what I was talking about, or you thought it was the nerdiest, coolest thing I've ever done. I guess I'll take it. Next week, we have a new Footnotes all about the Magic the Gathering episode. We have a new episode going up, and may or may not be kind of super villainy, and we have another live stream. Have a wonderful rest of your weekend. Go to teamtrees.org and donate some trees. We're almost there. We're going to nail it, and have a great rest of your weekend, and be nice to each other. Because aside from, if you don't have a tree to hug, you and me, it's all we got. Don't touch me, though. Fist bump. Hug someone else. I don't know. Not me, though.